Hey guys, what's the world? In this video, we're going to be talking about regressions and inverse functions, and really just inverses in general. What regression is essentially like it's kind of, to me, it's one of the cooler things in math. It's essentially scientists like gather data, they gather temperatures or whatever, and then with that data, they can use an equation or essentially regression based on the data. They can create a line best fit. That's what it's called. Essentially, we have a bunch of points, say blah 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 jabba dibba dabba dee, right? That's our data. So what we can do is scientists will create a line that, based on the data they see, will best predict what's going to happen, say, in the future. So based on what we know, we can start to follow the pattern and predict what could happen based on what we know. Very scientific, very kind of like data driven. So that's why I like this stuff. That's how my brain works. Like I said, regression gives us an equation that best fits data that we have either found or data we have been given. We'll use a calculator to find this equation every single time. So I'm going to do it on a TI-84 Plus. That is what we have in my classroom. This works the same way on TI-83s, so I will walk you through the steps. So just make sure that you pay attention when I'm walking you through the steps. All right, here we go. All right, so with this example, it says write the equation of the line best fit with linear regression. Then estimate the output when x equals 12. We'll round to the nearest thousandth. So we're given a bunch of data here. So we're given all these x and y values. So what we're going to do, like I said, everything is going to be done in the calculator. So with that data, the first thing that you are going to hit is stat, because we're going to do some statistical data with this. We're going to analyze this data. So hit stat. It will pull up this screen. First thing we're going to have to do is choose edit. We need to edit our list. So all I do is press enter and it brings me there. List 1 is usually what you'll put in there is your inputs. So we have 3, we have 5, 8, and 10. So I'm just hitting the numbers, and after I hit the number, I press enter, and it will automatically do it. Then I can hit my right arrow such that I need to enter the y values that are associated with those. So 3, -3, -10, -30, -36, and -80. Okay, so notice something's a little bit off. Something didn't show up. So I have -3, -10, -30, -36, -80. That means I missed a point here. So 3, 5, 8, 10, and I didn't type 30. So I'll go back and I'll type 30. So it's always easy to fix things. If you need to delete something, if you added too much, you can just choose whatever you want to delete, and you can press delete, and it will delete that thing for you. All right, so now we have all of our x's lined up with all of our y's, so just like our data does. So I will quit out of that screen. So I just hit second and then mode, which says quit right above there, right? It's in blue. Now we can actually do the analysis by going back to stat, except now I want to calculate something. So I'll move over. So I just press the right button so I can do some calculations with it. And the thing that we want to do, there's lots of options. See, all these reg ones are all regressions. So these are all different type of regressions that we are able to do. You'll learn about some of these in pre-cal this year, or sorry, you're not in pre-cal yet, in Algebra 2 this year, and you will learn about some of these in pre-cal in the future, and then some in calculus, and even statistics, whatever you may pick. But today we're going to be doing linear regression, L-I-N-R-E-G. We can see by the equation that that is a linear equation. So I will choose that. I pressed enter. Takes me back to my main screen. I will press enter again, and it does all the calculations for you. So notice it says your equation is y equals ax plus b, where a is this, -2.714953271, and it would go on, but b is -1.3925243, whatever, right? It says round to the nearest thousandth, so from the ones we will go tenth, hundredths, thousandths, so essentially 3 decimal places. So I can put these in the spot in the equation such that my equation is -2.715x minus 1.393. Right, so again, there's that, and there's my equation. It's -2.715. I round it up. because the next number was a 9, and negative 1.393, again I rounded up because the next number was a 5. So now that we have our equation, right, that's the line best fit, and that's what that is. It says then estimate the output when x equals 12. So all I'm going to do, sorry, there we go. So all I'm going to do, estimate the output when x equals 12. So I can say y equals negative 2.715 times 12 minus 1.393. And then you're just going to do the calculation so that when x is 12, y would be negative 33.973. That's really all you're doing to this stuff. All right, I'm going to look at another one. All right, so with this one, we're given some data, and it says in the x values and our inputs, it says the years since 2000. So that means this will be 2001, 2004, 2008, 2010, 2015. Right? The year since 2000. 1 year since 2000 would be 2001. And it says how many monkeys. We don't know really what we're talking about. It could be how many monkeys pick their nose. I don't know. And it's probably about right. I don't know. But first thing that we're going to do is actually put our stuff into our calculator, because it says write the linear equation that models the data. So I will go back to Stat. I will choose Edit because I want to edit my data. And you don't have to clear everything out. You can actually just start typing. So notice I hit 1 down at the bottom, and it will replace my 3 with a 1. So I have 1, 4, 8, 10, and 15. 15. And then I will choose my y values. So I have 50, 60, 67, 73, and 84. Double checking all my values, and they look good, I'm pretty sure. Hopefully I'm not making a mistake. All right, so now write the linear equation that best models the data. So I'll go back to Stat. I will choose Calc, and we want to do linear regression. Again, it'll take you back to your main screen. Press Enter, and it will tell you your linear equation. So I'm just going to copy that down. So we have y equals 2.369x plus 48.799. Right? Looks good. Okay, so then it says predict how many monkeys there will be in 2020. Well, notice since 2000, so 2020, my time would be 20, and my x value would be 20. So I want to put in, come back, y equals 2.369 times 20 plus 48.799. So 2.369 times 20 plus 48.799. I got 96.179. Hopefully that's what you got too. Now it says how many years until there are 200 monkeys. Well, it's going to be a little bit yet. I mean, 20 years, there are only 96. So we want to know our x value now, right? We want to know how many years, or what the x value is, but it's telling us the y value is 200. So I can say 200 equals 2.369x plus 48.799. And then that's just an equation that's pretty easy to solve. It's just weird looking numbers. So we can do 200 minus that 48.799, such that we have 151.201 equals 2.369x. And then just divide both sides by that 2.369. So divided by 2.369, we should come out with x equals 63.82 years. So really, after how many years, if it's saying after how many total years, we would say total years would be 64 total years. Because it doesn't hit that 200 until part the way through the 63rd year. So 64 total years, or if it's just asking how many years, you can say 63.82. All right, let's talk about inverses now. So with inverses, what an inverse function is, oh, I messed up. You see my mess up? No, go away. Given a relation, the inverse is found by switching the variables. So switching the variables exactly where they are. So like if I have the point 1, 2, the inverse of that would be 2, 1. Say if we have the equation y equals x minus 18, the inverse, we can find it by switching the variables exactly where they are, so I would start by saying x equals y minus 18, and then we would add the 18 to the side, so the inverse of this is the inverse notation, y to the negative 1, or f to the negative 1 inverse, which we will show in just a minute, would be x plus 18. They kind of just have the opposite relations. We use this for, in this instance, like this, where we knew our output, but we wanted to figure out what input we had in order to get that output. In finding the inverse, it just makes it easier to predict what our input needs to be based on what output we want. And we can kind of use that going forward. All right, so this first one here. Boo! All right, find the inverse R of each relation S. So I'm given a relation S where I have an X and a Y value, X and a Y value, X and a Y value. Again, we're just going to switch spaces. So the inverse, or R, would be 2, 1, negative 2, 3, and 8, 4. That is how you would find the inverse. Cool. All right, likewise, we're given some x values and some y values. I just want to switch the x and y values exactly where they are. So negative 8, negative 2, 1, 0, and 21, 2. That's it. And that's all an inverse is. It switches the x and y or the variables wherever they are. So for each function, f of x, write the equation of the inverse. So again, we have input x. Say if we want to know our output, all that does is finding the inverse. It just makes it easier to figure out what the input would be in order to get certain outputs. So the way we go about doing this is we switch the x and y exactly where they are. So remember, f of x kind of stands for our y value, or our outputs. So if I switch them exactly where they are, I would come out with x equals y plus 4. And the way we're going to write this f negative 1, all this negative 1 means is inverse. So f inverse of x, that's how this is read. F inverse of x. If we had g of x, we could say g inverse of x, or whatever inverse of x. So now, we want to solve this for y, so all I need to do is subtract the 4 to the other side. So I would have y equals x minus 4. Use inverse notation, so we will rewrite this as f inverse of x equals the equation x minus 4. That is what I'm going to be looking for there. All right, let's show you another one. So b here, we're given f of x is 1/3 x minus 6. So again, you're not going to change anything else other than just switching the x and y exactly where they are to help you find the inverse. So x and y is switched exactly where they are. Now I'm just going to go about resolving for y. So I'll need to add 6 to the other side first. So x plus 6 is 1/3 y. To get rid of this fraction, I can multiply both sides by 3 by the denominator. So this would be 3x plus 18 equals y. And then just rewrite this using inverse notation. So since this is f of x, my inverse will be f inverse of x equals 3x plus 18. And that's it. All right, so now, the way that we are going to prove that two functions are inverses of each other, because every now and then in math, just to make sure that something works out, we want to show that it actually does. And the way that we do this algebraically, instead of actually finding the inverse, is we want to show that function composition, both ways, f of g of x and g of f of x, both simplify to be x. So it's going to be pretty simple, but if it doesn't simplify to be x, then they're not actually inverse functions of each other. So it's a way to check your work as well if you're trying to find the inverse and make sure that you did your work correctly. So we have determine if f and g are inverse functions of each other. So again, we'll just do function composition, just like we were doing in the last section. F of g of x and g of f of x. So f of g of x, I'm going to take g of x and substitute it into my function. So f of 7x minus 1 divided by 2. Zoom in a little bit, make it a little bit bigger for you guys. All right, so now go to f. This is our new x value. So it's going to look really weird at first, but it'll simplify fast, I promise. So go to f. So go to f. My variable is right there. So I have 2 times my variable plus 1 divided by 7. So 2 times my variable plus 1 divided by 7. All right, so now check this out. 2 divided by 2 makes 1. So I'm left with 7x minus 1 plus 1 divided by 7. Negative 1 plus 1 is 0. 7 divided by 7 is 1. So this just simplifies to x in the end. We are good in that direction. Likewise, in the g of x direction, g of f of x. So I want g of what f of x is, 2x plus 1 divided by 7. So I'm going to take this, substitute it into my x for g of x. So 7 times my new x value. Now again, 7 divided by 7 makes 1. 1 minus 1 will make 0. So I have 2x over 2. 2 divided by 2 makes 1. So I am left with x in the end here as well. Since it is x in both directions, then yes, these are inverses of each other. And this is all the proof that I need. So yes, because f of g of x equals x, and g of f of x equals x. Cool. All right, last one, and then we're done. Last one and we're done. All right, so we have, again, shown that these are inverses of each other, f of g of x and g of f of x. We have to show that it comes down to x in both ways. If it doesn't work in one direction, then we're already done. So f of g of x, so f of what g of x is, so 1/2 x minus 4. So now go to f, substitute this into your x. So 2 times our new x value plus 4. So now I need to distribute this 2 throughout that. So 2 times 1/2 is x. 2 times negative 4 is negative 8 plus 4. Well, poop. I'm left with x minus 4. So all that means is that I'm done. I'm pretty sure I've done my math right. I'll go back and check again. 2 times 1/2 is 1. Yep. 2 times negative 4 is negative 8. Yep. Negative 8 plus 4 is negative 4. Yep. Yep. So these are not inverse functions of each other. So you could say, no, they're not inverse functions of each other, because for sure, f of g of x does not equal x. All right, hopefully this video was helpful for you guys. Please, 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 please come ask me questions. I know there's lots of new stuff. Again, maybe I'll draw a monkey on your paper if you are nice to me. All right, see y'all soon. Well, bye.